All right, the third test is the chi-squared test for homogeneity, basically. So when we did independence, it does not differentiate between response and explanatory. So the previous problem we did was your hepatitis C status and your tattoo status. As to which one of those is the response and explanatory variable, this input and output, who knows, right? We're just figuring out whether they are independent of each other or not. So when the response variables is identified, okay, and the population conditions are identical across the levels of explanatory variable, they are said to be homogeneous. I have a hard time saying that. All right, so this third one's called the chi-squared test of homogeneity. This test uses to determine whether the frequency distribution of a categorical variable is similar across different populations. So again, this is another two-way test because again, rows and columns, right? It's two ways, right? The null hypothesis, the assumption that the distributions are the same for each group, and the distributions are not the same for each group. As to what that distribution is, who knows? It could be normal, it could be uniform, it could be anything, right? Or unspecified, just being the same. It doesn't really matter. So let's say here we want to know if the plans of students from a large university are the same after graduating from different colleges within the university, right? So in this, we're specifying, right? So your response variable is your school, right? And your explanatory variable is the outcome. Are you going to be employed after school? Or are you going to go to graduate school or something other? Maybe that's military. I'm not really sure. But so that one we know which one is explanatory and response as far as the variables go. And we're trying to see if all of the outcomes are the same distribution. So if whether agricultural school, art and science, engineer, I forget what ILR is, but is the distribution the same for all of them, or is it a different expected outcome as far as the distribution? So we made the histograms so they look different essentially, right? So this is a chi-squared test for homogeneity. So this one and the independence are very similar. You have to pay attention to the wording. They don't always use the word independence or distribution or something like that. They're, might be implied with the wording, I keep doing that every time. There we go. Okay, so format, color, blue. I definitely read the book and see the variations of how they do this versus how I do this as far as the wording goes. The students come on, style text. The students post-graduation activities are distributed in the same way for all four colleges. So basically, homogeneity. Right? I don't know what happened there. Okay. Copy. Do not have the same distribution. Alright, I don't know if saying postgraduate activities is the best wording. I mean, it's obviously postgraduate. After you graduate, what are you doing? Probably could word that better, but that'll work. All right, so degrees of freedom is the same for this test as it was the last. So both the two-way tables are the same. Both two-way tests are the same. So this is 3 minus 1 and 4 minus 1, I believe, right? If we look back here. Yep, 3 rows, 4 columns. Okay, so that's 2 and 3, 4, 6. So my area is going to be chi squared dot distribution dot rt. Okay, so what you'll notice is the calculations are the same. It's the wording that's different, basically, and what you're concluding. All right, so I'm going to take this and first off, box it up. I don't know why it's not boxed. Copy. Put this into tab 3. Okay. I don't know why it keeps doing that. So obviously the table is observed because that's your samples, right? They never say that, but you're supposed to know. Okay. Ooh, something went wrong here. So we lost our things over here. What happened? Why is that not copying? There we go. Let's try that again. There we go. I don't know what happened there. Okay, so we'll center that out. It was necessary to make these bigger, but either way. All right, so the sum of these ones, drag it down, and the sum of these ones, drag it over, and then the grand total of all of those. Okay, so we're going to take this, copy, paste, and we'll put expected here, delete all those, highlight, hit delete, right? Remember the formula? It's the same as before, right? Row total times column total divided by the grand total. Okay, and you can probably just drag it across, but you'll get the wrong answers, right? Because if you notice, it's going to change them, right? See that how it changed? So what I'm going to do is I'm going to make the F6 not change with a dollar sign, right? So when I drag it across, at least that doesn't change. But if you look though, this changed. I don't want that to change, right? I want the F3 not to change also, right? So F3 also doesn't change. Because essentially, as you drag left to right, you're only changing the columns, right? There we go. I'm going to do the next one. Row times column divided by grand total, right? So if I drag this across, I'm only changing the column, right? I'm not changing the grand total when I drag it to the right, right? And I'm not changing the row. I'm only changing the column when I drag it to the right, right? Okay, last one. Row times column divided by grand total, right? So if I drag it to the right, I'm not changing the grand total, and I'm not changing the row. I'm only changing the column as I drag it across, right? So I drag it across. Now if I click this, right, row times column divided by grand total, right? Well, row total, column total, grand total. Or I think they call it table total, but either way. Okay, so then we need the components now. So we'll just take this and merge them together. There's merge there, or you can go up to here and merge them. Right, so this will be components, bold box, and then we'll need to box these ones. There we go. Okay, so we do the formula. It's the same as it is for all three type of tests, right? It is observed minus expected squared divided by expected. Okay, I should be able to drag that across, drag that down, right? Observed minus expected divided by expected, right? I think I just need to make this bigger maybe. Yeah, that's all that was. All right, so if I add all these up, add all those up, that is going to be my chi squared, right? So 93,65667, good enough. I'll just say 93,66, that's close enough. Okay, So 93.66 dot 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 comma 6 for the degrees of freedom. Let's get our area now. So our area equals, so chi-squared distribution right tail. There's my chi minus the degrees of freedom. So I get really small numbers. So that's the decimal's right there. So I move it over once. It goes over to here. Then 17 more zeros. I get it over there, right? So 17 zeros in the 5, right? All right. So let's go to here. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2. Right? Hopefully I got that correct. Let's do that again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 2 more is 17. I don't think it's going to matter if I got it actually wrong, to be honest with you. But and then a 5, 2, 6. All right, so that is my p-value. So obviously the p-value is way less than alpha, no matter what alpha is. Again, it didn't specify, so we're going to use the Fisher rule, which is 0.05. Whoop, 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 whoop. So we're going to reject the null hypothesis. All right, so remember what we got. General understanding. Right, this is my chi-squared, right, which we got over here. That's my critical region. So this is 0.05, right? But we got to this area, which means it's a very small area, right? So this area is right here. So it's definitely in the critical region, essentially, is what we found, right? Because our area is very small, and our alpha is 0.05. Okay, so let's click down here. So there is enough evidence to reject the null hypothesis. We're in the critical region. The sample is not expected, right? So it's an expected sample would fall within the non-shaded range. Is oh, that's the best. Not expected. Critical. What did I put? I forget what I put before. Significant. That's the better way to put it. Our sample is significant. Of course, it's not expected because you shouldn't expect to get one in that range, right? The postgraduate activities of students from the 4 colleges is likely, or let's put likely, do not have the same distribution. As to what that distribution is, we don't know. It doesn't really matter. We're just saying they're not the same. That's the point, right? So basically, depending where you go to school, the outcome of what you're going to do after school is going to vary, depend on what school you are. So if we hadn't, so if it wasn't significant, we would have basically said it's the same no matter what. But clearly, it's not essentially. Okay, so that's the end of.